Welcome everyone to another episode of the To Till or Not To Till series run by Agricology. Today we have someone that is very well versed in this topic, and we're going to cover quite a few different facets of the whole concept of to till or not to till. When you hear his extensive experience, you'll realise just how qualified he is to talk on this topic. And that guest today is Jonathan Storkey. Jonathan, would you like to say hello?
Hello, hi.
How are you doing? Are you well?
I'm doing well, thank you. Enjoying the weather.
What does this time of year involve for you at the minute?
We're just getting going with the field work. We've got 2 or 3 projects on the go at the moment that involve large-scale surveys of UK farms. So we're looking at beneficial insects, we're looking at pests, weeds and diseases. So that involves a lot of travelling around the country and walking fields.
Yeah, and as you said, it really is the weather for it at the minute.
It is.
It's pretty stunning. I don't know when this is released if we'll be saying the same things, but we're filming this on just the start of April in this absolutely lovely weather. That even up in Scotland here, when we're outside, we're wearing t-shirts and shorts. So we can't complain at that. Just before we get into these, Jonathan, it's really good to hear a bit of backstory about a guest, sort of what makes them tick, what their story's been, I guess. Just before we kick off, so what's the story of Jonathan Storkey?
Okay, well, I'm actually a trained ecologist. So growing up, I was interested in natural history. I was a bit of a birder. I was always out walking. And so I chose biological sciences and ecology at university, always interested in the natural world and specifically how we depend on the natural world for our well-being, and our economy is also very dependent on ecology. So at the end of that degree, I went on to do a master's in agronomy and then started working back at Rothamsted in the 1990s. And I started off as a weed scientist. So some of the audience might be familiar with the name Stephen Moss or Peter Luttman. Stephen Moss was very active in the area of herbicide resistance at the time. So I was working alongside Stephen for many years. And the focus back then was on weed competition and really the economics of herbicide use and weed control. So whether we could identify weed populations or weed thresholds which were not economic to treat. So they were low enough that the competitive loss was going to be lower than what you'd spend on the herbicides. But then through to the late 90s and early 2000s, when agri-environment subsidies started, there was a renewed interest in biodiversity on farmland and maybe the biodiversity value of some of these weed species like chickweed that we were spraying off. So then the ecologist in me started to take over, and I became interested in how we reconcile production and economic crop production with the conservation of biodiversity, and specifically that biodiversity that does something for us, that contributes to the production system. And more recently, that interest has fed into the whole conversation around regenerative agriculture. How do we invest in the biodiversity? How do we encourage the biodiversity? And how do we maximise the benefit that biodiversity is giving for our crop production systems?
Just on that, I think that's a really important question to bring up there, Jonathan, because we all talk about the importance of biodiversity, but as you say, you made a really good way of putting it there, that biodiversity that does something. What examples of biodiversity we're seeing that does do something in a farm system?
So in the research circles, we tend to call this functional biodiversity. So it's the biodiversity that has a function within the cropping system. And another kind of technical term in the research field is ecological intensification. So if you build up these populations of these beneficial, mainly invertebrates, but some of the soil fauna as well, they're delivering something for the production. So the most obvious one is pollinators. That's the one that people generally reach for first. So if your pollinator populations are depleted, you might have reduced yields of, for example, your field beans, which rely on those pollinators. But also there are natural enemies of crop pests. There are the beetles that eat the weed seeds. So these biodiversity is effectively suppressing or regulating those pest and weed populations and reducing them to lower levels. And then, of course, we've got all the biodiversity in the soil, the microbiology and the worms that you find in the soil that are a component of that soil health and soil function.
You also mentioned there, Jonathan, about your extensive time at Rothamsted since the 90s, which is pretty impressive. One thing that we had talked about between yourself, Matt, and I was these long-term tillage trials that's happening. Could you tell us what they involve? Are they long-term in that they're starting now with a focus on long-term, or have they been going for a while?
Yeah, so Rothamsted is famous for its long-term trials. It has the longest running field experiment in the world, Broadbork, which started in 1843. And those trials tended to be focused on one management option, mainly fertilizers, so changing the rates of fertilizers or combinations of fertilizers, and looking at the response of one or two things. So it might be yield or it might be soil carbon. The new experiments that we set up back in 2017 have a slightly different approach. And to answer your question, yes, they are intended to be long-term. They're intended to be new experiments that complement the existing historical experiments that we have. So they started in 2017 and 2018 at two sites. It's the same design. And so they're now coming into their seventh and eighth year. And we took a different approach to those experiments. So, and which reflects some of the evolving science at Rothamsted as well. So we weren't just interested in what happens if you change one thing, fertilizers, tillage, rotation on, for example, yield. We're interested in what happens if you pull multiple levers, if you change multiple things, and how does that affect multiple outcomes? So you could call it a systems-based approach. Mm-hmm. We're contrasting, instead of contrasting two approaches to fertilization or two approaches to tillage, we're contrasting different systems in which there's multiple moving parts. And that's quite a challenge for us as scientists, but I think a very powerful way to do the science that we need to answer some of the research questions that we've got.
One of the massive themes that's came up in this series, and I think I've said this 3 or 4 times throughout, is this whole concept of context. And it's so valuable. I mean, I think you're right. I mean, when I think of a field trial, I'm like, well, you'll do this one with a fully conventionally ploughed system. You'll do this one with strip tillage, for example. You do this one with none, and that's it. Which is way too blanket. There's so much more to that is valuable. But just looking at that, Jonathan, you said there's a trial at Rothamsted that will be in its 18th decade by the sound of it. 8 years is quite in its infancy, I assume. But are you starting to find things? What things are cropping up as themes that you're seeing?
We are. So you're right in saying that it's early days. So particularly if you're looking at some of the processes like carbon sequestration and changes in soil properties, they do take 5 years, 10 years, decades really to become evident. But we are seeing different systems move in different trajectories. So we're seeing indications. So all of the plots started in the same place, and we're now starting to push them down different trajectories. So we're starting to see divergence in the plots in terms of the weed flora. We're starting to see divergence in the plots in terms of soil properties, soil carbon. We're starting to see differences in yield, and some of those differences in yield are starting to change as time goes on. So the initial yield penalty from reduced tillage is reducing as time goes on, but the rate of that reduction in the yield penalty again is context specific, differs between the plots. So yes, the longest rotation on the experiment is 7 years. So I should say the experiment is sown at 2 sites. One is Harpenden, which is a clay loam, and one is at Broomsbarn, which is a sandy loam. So you have contrasting soil types. It was sown at Broomsbarn in 2017, Harpenden in 2018. And the longest rotation is 7 years. So this year we will have gone through the longest rotation at both sites. So it was a good opportunity to take stock and see what changes have happened over that time period.
But when we focus, I guess, with a particular focus on tillage, not because it's all I'm interested in, but this is the series looking at tillage. How can we, I guess, understand approaches for the producer using whichever format that is, and how does the difference between, as I said earlier, a conventional system and a no-till and everything in between impact the opportunities that farmers are having on that patch of land?
Yeah, I mean, you mentioned the issue of context before. And we know that that's really important. So what will work well on one soil type, less so on another. So For example, on the heavy clay, we've struggled. We were using a Simtech direct drill, and certainly if we were in a drier autumn, the slots wouldn't close up, and we would find that the rooks were going along and taking the seeds, and we were getting poor seed to soil contact and poor emergence. Less of a problem on the sandy loam. So the how well individual technologies or approaches work will obviously depend on the soil type, and we're seeing that. But also we're seeing the effect of the tillage, or the impact of the tillage on yields, is dependent on what else is going on in the system. So it's not only the context of your environmental context, what your soil type is like, but also what else is happening in the system. And I think one of the big messages that I would want to get across is that the effect of reduced tillage depends on where you are and what else you're doing in the system. So, for example, we're finding that the combination of reduced tillage plus green compost plus cover crops plus a perennial lay in the annual rotation is giving you added benefits, is having synergistic effects. So, in the regen ag conversation, layering these principles is absolutely crucial. So it's very difficult to do a reduced tillage if you've not got your cover crops and your green cover and your organic amendments as well, that effectively facilitate that transition and ease that transition.
Have you came across examples where reduced tillage is too subjective, let's go with no tillage, isn't actually viable? And considering all those parts you've mentioned there, Jonathan, where a conventional system would have worked, or is there always place for it? It's just in varying levels of success.
Yeah, difficult to say. Certainly, anecdotally, we're hearing about people running into problems, and the obvious one is weed control and the buildup of weeds. And we're seeing on that on our experiment as well, specifically grass weeds and perennials. So we know that these systems are very reliant on glyphosate in controlling the weeds. And there was an announcement, I think, earlier this year about the first glyphosate-resistant weed being recorded in the UK. So that heavy reliance on glyphosate could potentially mean these systems run into problems with weed control and herbicide resistance.
Quite an amazing thought that's even a thing. Is there's potential for a glyphosate resistant weed. It's just what we've known my entire life is something that nothing is resistant to this. It's gonna kill out everything, and it'll be a big change if that increases over time.
Well, it will, and if you think about the way that we use glyphosate in a ploughed system, you might have a stale seed bed. You might use delayed drilling to control your blackgrass, but you would have maybe one or two applications of glyphosate in your stubble before you sowed your autumn crop. But then you're going to have a cultivation. So any of those survivors of the glyphosate, any individuals of blackgrass or brome or whatever it is that survives that glyphosate, is likely going to be killed by the cultivation treatment, the harrowing and the drilling. So that individual that might have the resistant alleles doesn't have the opportunity to go on and then produce seed and propagate. But if you're in a reduced till system, that glyphosate resistant weed will probably go on to set seed. And so I think that's the potential Achilles heel in the system, and that we're giving these survivors an opportunity to reproduce and pass on that resistance trait to the next generation. Then potentially we might be in a mess.
Focusing particularly on soil biology, what differences are we seeing in microbial activity across, again, those tillage systems?
So the helpful thing that I like to keep in mind is that a till system, a regularly cultivated system, is being kept in an early stage of succession. If you can remember from school, vegetation succession. So you have your early stage communities, and the most extreme examples, volcanic islands that have just emerged. And then you gradually get a succession through your annual plants through to your perennials and then your woody perennials. So you have that succession. In a ploughed system, we are maintaining the system in a very early successional state. So we're effectively resetting the system every year if we're using annual ploughing. And what that means is that you select for a microbial community that is adapted to that early successional state. So they tend to be, you tend to get a high turnover of nutrients. They tend to be leaky systems. Whereas when you move to, and dominated by bacteria rather than fungal communities. If you reduce the tillage and the longer you stop ploughing and move into this, are we talking using zero till? I can't remember what the phrase was.
We can talk whatever we get. Yeah, just
yeah. The longer we don't plough or cultivate that soil, then we're moving to a later successional microbial community, which is more adapted to hold on to those nutrients. So the cogs are moving more slowly, if you like, and the system is more efficient and less leaky. So we're holding on to nutrients more tightly, and those communities tend to be more dominated by fungal communities, which also tend to be more efficient for nutrient use and more resilient against extreme events. So the difference is those early successional bacteria-dominated communities versus later successional fungal-dominated communities.
I was expecting you to go into microbial communities, but could you just expand a wee bit on what they are and what role they play in the system? Because as you're saying, they can differ between fungal, bacterial, but what in general are they and how do they operate?
So here I'm going to reference my colleague Andy Neal, which some folks might be familiar with. He's done some really nice work demonstrating how the function of soils is related to the microbial. I'm not an expert in this, so what you're hearing is largely what I understand from Andy's talks and Andy's papers. So his argument is that the soil is an expression of biological processes. So you can't just understand the impact of changing your tillage on the physical structure of the soils without understanding the impact of that tillage on the microbial communities, on the bacterial, on the fungal communities. Because those communities are effectively mediating the soil structure or the soil functions. Specifically, they're creating the glue that binds together the soil particles and creates the porosity in the soil space, which then feeds through to water retention, that feeds through to infiltration and aeration of those soils. So a soil with better pore structure, connected porosity, will function better in terms of management of water and management of nutrients. And that greater pore space is a product of the functioning of that microbial community.
You've made that very articulate for someone who's not an expert on it, Jonathan, it must be said.
And so again, in understanding that, in understanding the assembly and the function of the soil microbiome, yes, the physical disturbance from tillage is going to be important, but that needs to be understood in combination with the soil organic matter, with the carbon inputs that are coming into the system, which is also a really important driver of the type of microbiome that you have and the function of that microbiome. So the best scenario is reduced tillage with carbon inputs, with increasing soil organic matter, and that will lead to the most beneficial soil microbiome and the best soil structure.
What about a focus on IPM? What differences are we seeing again? I don't need to keep saying across tillages. We know that's what we're talking about, across that sort of conventional to no-till and what's in between.
So it's a mixed picture, I think, when it comes to IPM. I've mentioned weeds, and we know that tillage is a really important tool for managing weeds, particularly if you want to reduce reliance on herbicides. So again, to disrupt the weed life cycle, we're relying on some kind of disturbance, and a herbicide can be a disturbance, and a physical cultivation of the soil can be a disturbance. So it's either, at the moment, we're kind of stuck in that either or when we're managing weeds. We either control them chemically, which can lead to herbicide resistance, or we control them physically, either through cultivation of the soil or mechanical weed control. So I think reduced tillage systems are obviously a challenge for sustainable weed control. There may be a place for rotational tillage, And this was certainly something that Stephen Moss would argue for, ploughing once very well, but only occasionally. So if there is a buildup of weed seeds on the surface, you bury those. When we think about pest control and beneficial insects, it's pretty unequivocal that reduced tillage is good for populations of beneficial invertebrates, whether that be ground beetles, carabids, which overwinter in the soil, either as larvae or pupae. And again, I'll reference one of my colleagues, Kelly Jowett, that people might be familiar with. She's very active in this area and speaks very well on this. Ploughing and cultivation of the soil can disrupt the populations and life cycle of those beneficial carabids, which eat slugs, they eat aphids, they eat weed seeds. And also it can disrupt the life cycle of parasitoids. So we've got evidence from our new long-term experiment that if you contrast a reduced tillage and a ploughed system in a winter wheat following an oilseed rape, the oilseed rape parasitoid adults, which overwintered in the soil after the previous crop, are higher in the reduced tillage system. So they're emerging in the winter wheat, but then they will then fly off and control the cabbage stem flea beetle or the pollen beetle in the neighbouring oilseed rape crop. So for weeds, it's kind of a mixed picture because we are so reliant on tillage for weed control. When it comes to integrated pest management, it's a fairly simple story that reduced tillage is better. Slugs is another story, and there's an issue with slugs with the retention of residues and trash on the surface. So again, maybe a slight minus on that side of things. So it's a mixed bag, and it's certainly too simple to say that conservation agriculture or reduced tillage is good for pest, weed and disease control. That's too simplistic. It's a much more nuanced picture, and I think the challenge for us is understanding the potential trade-offs of moving to a reduced tillage system, whether it be for weeds, for slugs or soil-borne diseases, and then coming up with mitigation strategies that might reduce those negative impacts while retaining the benefits of the reduced soil disturbance.
You mentioned about rotational tillage there, and this is interesting to me. I find this really interesting. What sort of span of time are we talking between ploughings? Could that be 3 years, 10 years? What are you looking at?
I think this is an important research question, and I'd be interested to know if anyone has the answer to this. In my mind, and this is just intuitively, I'm thinking of a timescale of around 5 years in terms of weed control and controlling something like blackgrass. But understanding is, and I may be wrong, that this is a piece of science that needs to be done in terms of if we do move towards a rotational tillage system and maybe a ploughing once every 3-5 years. How much of the good does that undo in terms of the build-up of your benefits over that 5-year period? For example, the development of fungal networks in the soil, the build-up of worm populations, increasing soil carbon, all of the good stuff that we know we're reducing tillage to improve. If we have a single ploughing event, how much of that good is lost? Do we go back to ground zero, or are we, we're keeping some of those benefits? So I think there's a really interesting piece of science to be done around that trade-off between retaining the benefits of your reduced tillage system and maximising the benefits of that single ploughing event. Interestingly, at the site in Brooms Barn, our experiment we call the large-scale rotation experiment. At Brooms Barn, we have, in the 7-year rotation, we have sugar beet. So we have a set of plots that are nominally zero till in a 7-year rotation, but they have sugar beet in them. So we are ploughing once every 7th year because we've got a root crop. And so we will have the data to answer that question for that one site. We'll be able to look at the soil properties, the weed communities, the worm communities in plots that were ploughed last year, 2 years ago, 3 years ago, and up to 6 years ago. And that's one analysis that we'd like to do. So I think the question you ask is really interesting. I don't think we have the answer yet, but it's a real knowledge gap.
And albeit there's a knowledge gap, just I'd be interested to hear your thoughts on between those ploughing events, be that 3, 5, 7, whatever it is years, are we completely no tilling and direct drilling, or are we minimum tilling, or what's sort of fitting in between those ploughing years?
Again, I think we need to be open to adapting the system and doing some surface cultivation. In my mind, there's a big difference between inversion and non-inversion tillage for a lot of the properties that we're looking at. But when it comes to something like soil carbon, I would imagine the difference between a shallow, 2 or 3 centimetre cultivation and no-till is relatively minimal, but the difference between a shallow cultivation and inversion tillage will be very large. So again, I don't have a straightforward answer, but I do think that we're going to have to be flexible and adaptable.
I don't think I'll ask a question in this series that has a straightforward answer. I don't think that's the type of thing we're working with. We're not working with absolutes. You're looking at pests, weeds, diseases, weather, climate, topography. There's so much to it that I think it's all what you're saying. There's no yes, no.
Yeah, and it's certainly the case that we can't say that no-till is good for everything. It's clearly not. People have been ploughing for centuries for a reason. So the challenge is maximising the benefits of reducing our tillage and mitigating against some of the trade-offs. And that's where an experiment of the type that we're doing at Rothamsted and also Leeds University have a very similar experiment, which is very exciting, are helping to answer those questions. But equally, the farming community and more at Rothamsted, we're seeking to engage with the farming community because they are continually adapting their system. They're finding solutions to these challenges and these trade-offs. So the more that we can have that two-way conversation and that exchange of ideas, so we can say, well, we've learned this from our experiment. What are you doing? What's your experience of no-till? What's your experience of weed control? How are you adapting to that? I think the more as a research institute we can cultivate that two-way interaction of knowledge, the better. And we're certainly not going to come up with the solutions in isolation on our own.
In a different world away from the Agricology podcast, I interview people on my own product, and I interviewed a regenerative organic vineyard. And at that point, when I interviewed that, it was a few years ago, the whole concept of those two words coming together seemed pretty alien to me. Is there successes or even potential for success having both an organic and a very minimal, if not no-till system together?
I'm not aware of it, no. Yeah. Because you also have the example with cover crops and how you destroy the cover crops and manage the cover crops. I know you can use grazing, so you can use mob grazing with sheep, but certainly if you've got a stockless system, I think it'd be very difficult to do it without glyphosate at the moment.
Yeah, it's an interesting concept because I've heard of a few people talking about it, and that's why I asked, because I don't know how. Here, if we don't consider these things, we're never going to push the envelope and see if we can get there. But it's interesting to see what stage that's potentially at the minute.
Yeah, I mean, one idea I've had in the past is whether you could start with an organic system. So what we tend to do is we start with a conventional system, high input system, with degraded soils and no biodiversity and all the rest of it, and we try and find approaches to restore the function, restore the resilience. So we're saying we're going to reduce tillage, we're going to reduce inputs, we're going to diversify the rotation and see if we can get to a more sustainable system that way. I've wondered whether it'd be interesting to start from the other end and start with an organic farm, which has got high biodiversity, might have high soil carbon. It's got the resilience, but it might have the lower yields. So it might be a third lower yielding or whatever. And so, okay, let's start from that and say, how can we build in the tools in a very kind of strategic and clever way? So, for example, glyphosate. You've got in your organic system, you've got a problem with docks, with thistles, whatever it is, and at the moment you're hand weeding those. What about if we allow strategic applications of glyphosate? but we do it at the absolute minimum that we need to get the benefit. And so you're gradually building in some of those technologies, but you're starting from the other end and see how much do you have to use to get to your sustainable system. I think that'd be interesting.
That would be interesting. Yeah, it's quite interesting to flip it and go with
Yeah.
that conventional way. I like that.
Yeah.
I like that. Let's speak middle ground, if you pardon the pun. The whole concept of strip tillage, nothing, and then your tilled crop in the ground next to it. Is that pointless? Is there strategy to that? Is it working? Is there challenges with it?
Again, I intuitively like the idea because it's like rotational ploughing. It's kind of a middle ground. It's trying to retain some of the benefits of that soil disturbance, for example, weed control and crop establishment, while also giving the soil an opportunity to regenerate, to build up its microbial communities, to build up its function that we've been talking about. So intuitively, I quite like the idea. I've not worked directly on those systems. I think what you do with those areas between the strip tillage, I think, is interesting in terms of what kind of permanent green cover do you have. You're effectively talking about some kind of understory and how you manage that and how you achieve the balance between whatever's in there, whether it be a white clover or whatever, gives you the benefit without becoming a competitive burden, for example, moisture in the spring. So I think there are challenges with the system, but again, I would put that in with the rotational ploughing as a potential middle ground and as a potential solution where we could balance the benefits of reduced tillage with some of these negative trade-offs.
We've mentioned carbon sequestration throughout, Jonathan. It's the big thing across all of agriculture now. It's the number one thing on folks' minds in a lot of different ways. I always think people will jump to, if you're ploughing, if you're doing some form of inversion tillage, your carbon sequestration isn't going to be as good as if you're not. But it's not that simple. What is it we're looking at from that perspective?
It's not that simple, and I think it's fair to say the benefits of reduced tillage on soil organic carbon are often overstated. And oftentimes what you see in the big analyses of multiple studies show is that often it's a redistribution of that carbon. And you might see, yes, higher concentrations in the top 5 centimetres where you have the buildup of the residues. But if you look at the whole plough layer down to, for example, 23 centimetres, you don't see the same kind of uplift, the same kind of difference. And in some studies, it's equivalent. So we need to think about, when we are comparing those systems, think about the depth to which we're sampling. But we are seeing, within that plough layer on our experiment, we are seeing increased soil organic carbon on our reduced tillage systems. So there is certainly potential. And the science would say if you're disturbing the soil, you are promoting the decomposition of soil organic matter. And so you might be accelerating the turnover of carbon. So there is an argument that you should be seeing increased soil organic carbon. And we are seeing that slowly on our experiment, but particularly when it's combined with organic inputs. So where we've got the addition of green compost, there we're seeing it increase faster, as you would expect. So yes, there can be a benefit of reduced tillage. It's sometimes overstated, but it is part of the picture.
Another thing that's been a thing we've mentioned a few times is resilience, and there's a lot of facets to resilience, obviously. But one thing I wanted to ask about was it's becoming more and more common for us to have weather events in the UK that aren't typical of the UK for what we've been used to, be that rain, droughts, whatever. Is there differing challenges to different levels of tillage with regard to droughts, floodings, and other examples of severe weather events?
Yeah, I think this is a really interesting question because, again, we would argue that a reduced tillage system is more resilient. So it should be more days that you can drive on it, It should have better water holding capacity in a drought, and it should have better infiltration during heavy rainfall events. So the science says a reduced till system should be more resilient. But the challenge is getting to that state in the context of our extreme weather events. So I'll just talk about a conversation we had at Loddington, at the Allerton Trust Game and Wildlife Conservation Farm at Loddington, where we had this, we were discussing the challenge of transitioning to a reduced till system or regenerative system in the context of extreme weather, in the context of having to maintain the profitability of the business. And so they knew what the right thing to do was, but they kept getting caught out by heavy rainfall events, by storms. So the analogy I came up with was you're trying to fix the car while doing 60 miles down the motorway. You're trying to, you know there are vulnerabilities and you want to address those, but at the same time you're trying to turn a profit and you're trying to get a decent crop off that field. So yes, the systems we're talking about, reduced cultivation, regenerative systems, they will be more resilient, but the challenge is getting to that state, given that we have these challenges with extreme weather in the meantime.
Yes, I mean it's a quickly changing climate environment. It really is, and it's an interesting thought and everything. You know, one of the things I loved, I was in New Zealand recently about New Zealand was there was a place that about 5 years ago they were like, do you know what? This isn't for dairy cows anymore. This is for kiwis. And I'm not saying we're going to go to kiwis, but that openness to be like, well, we've been a sheep farm for 120 years, but do you know what? Right now, it's not the thing, and that's a really progressive attitude. And I think we'll probably see a lot of people seeing changes in what they're doing, be that livestock, crop, whatever. You know,
inevitably, and I think we're increasingly realising our farm businesses and farm systems have developed in a different climate. So, and at the moment, we're just seeing them get stressed.
Yeah.
And there may be certain things you can adapt to and mitigate within that business and that system, whether it be a winter wheat, winter oilseed rape, based system. There may be certain things you can mitigate, but you're going to come to the point where actually, I can't do this anymore. Yeah, that's a really interesting question for the community.
Absolutely. As I've drawn these episodes to a close, Jonathan, there's one thing I've sort of tried to do, and it's always trying to incorporate that whole idea of context. And the way I've done it is sort of try and create scenarios, if you will. But the way I'm going to do it with yourself, and this is obviously going to be vague, it's going to be relatively surface level. But if you were to focus on, choose one of the places you've done most of your trials throughout your career, and you were going to start farming now, what would your considerations be? Would you be edging more towards conventional? Would you be edging more towards minimum? What would your thoughts be?
I think uppermost in my mind would be efficiency.
Okay.
So I've got a finite amount of water in my system. I'll have a finite amount of sunlight, growing days, or whatever it is. So how do I design a system that uses those natural resources as efficiently as possible? So using what nature is providing as efficiently as possible, such that when I need to add inorganic fertilizer, or I need to control weeds or pests, that I'm doing that as efficiently as possible. So the system and the environment is doing as much work for me as possible. So whether that means maintaining green cover, whether that means using legumes, whether that means building up populations of invertebrates that regulate my pest, weeds and diseases. So my starting point would be, how much can my local environment, my soils, my biodiversity, my water in my system do for me? Maximize that, and then think about the inputs. And so that would drive. I'm not an economist, I'm not a business person, so I don't know how this would work for farm economics, but I'm coming at it from an ecologist, from an agronomist. So I think I would be thinking about designing a cropping system which will include the integration of livestock that uses those natural resources most efficiently, that gets the most out of what nature is providing and the environment that I'm in. And then supplementing that with inputs. So saying, given I've got my legumes, given I've got my residual nitrogen, given I'm growing my cover crops and my residue management, I've got my good soil structure, I'm going to need a top up of bag nitrogen. But that top up will be reduced because I've got all of this stuff already going. Similarly with weed control, I know I'm going to have to use herbicides, but my reliance on those herbicides is lower because I've got this regulation through the rotation or through the biocontrol. So it's a different way of thinking about it. So you're starting with the ecology, you're starting with that functional biodiversity we were talking about, and then adding the inputs on top, rather than saying, how much fertilizer do I need to use to get the most profits out of this system? Does that make sense?
Yeah, absolutely.
So that's very much an ecologist's answer.
But I think that's what's interesting about this. I mean, I hate to use the word again, but context doesn't just refer to the place you're in, it also refers to the interest you have, the thing you focus on. And one thing that has become a massive theme of questioning, be that in podcasting or when I was a lecturer, was what does regenerative agriculture mean to you? It all started because McCain's, McDonald's, various companies mention it, and I'm like, I feel wrong about them mentioning this product without it having an objective definition.
Yeah, that's right.
The more times went on, people have said I'd rather it didn't have a definition, and it's been really interesting that, and I think that's context is also about opinion.
It is, and going back to what we were talking about before about contextualization, when I talk about regenerative agriculture now, yes, I talk about contextualization. What works well here won't work well over there. But then I also talk about this issue of categorization, which is a huge issue. You haven't got an organic category and a conventional category. And when we did science on organic, you could have a set of organic farms and a set of conventional farms, and you could compare and contrast biodiversity, yield, soils, whatever. You can't do that with regenerative agriculture. It's very difficult to say that farm is regenerative and that one isn't. They're on a gradient, and regenerative agriculture is a set of principles. What that means on the ground is that you have different ingredients, the same ingredients in different recipes. So some people will do reduced tillage cover cropping without grazing. Some will have grazing over there, which again emphasizes the need for the kind of science that we're doing at Rothamsted, which is looking at all these interactions and combinations in different systems and understanding what works where based on those first principles, based on our understanding of the response of the weeds, the response of the worms, the microbiology. And if we can understand the processes, then we can start to predict, okay, in this context, if you have this particular combination of ingredients in this recipe, we expect the soil carbon to go in this direction, we expect your yields to go in that direction. So it's it's a very interesting area to be working in, but far from straightforward.
Yeah, absolutely. It'd be boring if it was straightforward.
Quite, yes. Yeah.
Jonathan, it's been a pleasure having you on. It's been really interesting.
Good.
I've really enjoyed it. I hope you have too.
Excellent. Yeah, thank you very much for the opportunity.
Not at all. You were very much high on the list when we picked out the people we wanted to interview. So thank you very much. You're clearly a busy man, so thank you for the last hour of your time. I appreciate it hugely. And for those of you listening, if you've just found this episode, there is 4 others in this To Tell or Not to Tell series by Agricology, so go and check them out. We should be trying to run maybe different series throughout the year on different topics, so if you have ideas on what you would like to see, get in touch with Agricology or myself. But today has been Jonathan Storkey speaking all things research into To Tell or Not to Tell and much more. Thank you very much for listening, and we shall see you again soon.